Hello everyone. I hope everything is working and you may see us on YouTube. So I'm checking here on my small screen that everything is here and everything is working. So hello and welcome to the first JACOV webinar on YouTube. Hey, yeah, as we promised on JavaZD Day conference. I have sound on my iPad, so sorry about that. Okay, so this is first webinar. Yeah. Yeah, so I have small sound from different devices. So I think we will establish everything for the moment and everything will work. So this is first time we do this webinar here. So sorry for some technical troubles. We probably will have some. So I hope we'll fix everything and everything will be fine. Okay, so my name is Roman Meyerson and we're starting our webinar here on YouTube. So welcome. And before I will ask my today's speakers to join me in my virtual studio, I want to ask you to click subscribe button here down before the description, and also click the button with the bell so you won't miss notification about our further webinars. Also soon, very soon, we will have videos from JavaZD Day conference here on this channel, so please subscribe to our channel not to miss it. Also I want to say that we have a Telegram channel, so link also here in the description, so please join us in our Telegram channel. Some useful links and useful stuff will be there, so don't miss a chance and join us there. Also, we're always searching for speakers, so please, if you want to be a speaker or if you have a topic which you want to tell us on these webinars, in the description you may have my Telegram link, so please go forward, text me, and we would make the webinar with you, and this webinar would be here on YouTube, so don't miss a chance to be famous. Of course. Okay, so let me ask my today's speaker to join me here. Andriy, Dima, please turn on your cameras and microphones. Hi guys, how are you?
Good morning. I'm fine, thank you.
Hello, Ron.
Yeah, hello. Okay, so I would let me talk with you just a couple of minutes. I would check on the translation that we may see you there. Yeah, we may see you there. That's nice. So it's some lag between us and YouTube, so we need to think of it. Okay, guys. So just want to say that we have chat here in YouTube. So if you have any questions, so just pass them here in the chat, and we would ask these questions to our speakers. And of course, after the webinar, there would be time for them to answer your questions. Okay, so I think we may not waste time anymore, and I think we may start. So let's do it. Andriy, could you please share your screen so we would check that everything works fine?
Sure. Can you see my screen?
Yeah, we can, and I hope it would be on YouTube as well. So guys, from my side again, please subscribe on our channel, please click bell button, and also join us on Telegram channel not to miss news and stuff. And Andriy, Dima, good luck with your webinar. So let's go.
Thank you very much.
Thank you. So hi everyone, I'm happy to see you here, and today me and Dima are going to conduct a presentation about serverless patterns and best practices in AWS. This presentation appeared as a result of our hard work during like 18 months on one of the best insurance company in the world, and we've gained a lot of experience and some stuff which we should do and some stuff we should have done, and now we are going to share this experience with you. And actually, who are going to conduct this presentation? So me, I'm Andriy Trubitsyn. I'm a senior solution architect at EPAM, and my main focus area is microservices and serverless architecture. Also, I participate in many international conferences like JACOV, XP Days Ukraine, and some other local meetups in different cities of Ukraine. And Dmytro, Pasko.
Yeah, hello, Dmytro or Dima, Pasko. Good morning, everyone. Yeah, I'm working in the EPAM systems as an architect. Done a lot of interesting projects before, microservices, all kinds of stuff. I've been part of I take part in all parts of software development lifecycle, have several cloud experiences, and was a speaker in conference too. And now my passion is serverless.
Thank you,
let's
Dima.
discuss it.
Thank you. So actually, let me drop a couple of words what serverless is. I'm pretty sure that every one of you understands what it is, but just in case, so just let me remind that serverless computing, it's just a cloud computing execution model in which cloud provider takes care of all servers, and you don't have to bother about it. But when we are talking about serverless, it's not just about functions. We have to remember that serverless, it's like a more broader term, which includes some other services like serverless databases like Aurora RDS, which could be serverless, or it could be another service like Step Function, BPMN engine, serverless BPMN engine, or it could be even containerized service like ECS, Elastic Container Service, if you use Fargate. So serverless model, it's a little bit more wider than just functions. And working with serverless approach, we have to understand its advantages and its disadvantages. And all this stuff will be revealed in the next slides. So Dima, please.
Yeah, I'm going to share you why is this important from business point of view. What are business cases? There are 4 of them, and so the main idea of using serverless, so you will be focused on your business value and not spending time on developing infrastructure, and faster time to market, reduce cost, improve reliability, increased rate of innovation. It's things that we are going to discuss in next slides. So let's start with the first, our point is faster time to market. So as we already mentioned, so you won't take care about infrastructure because serverless platforms will take care about you. So usually all software contains from several parts. On top you have a business logic APIs, and you have a lot in the basement. Messaging, storage, databases, compute, physical infrastructure. So you're in serverless world, you're delegating all these parts to your serverless provider. So you will be focusing only on most important part of your application, which is business logics, your API, what really brings value for your business applications. So you won't spend a lot of time to set up a kind of infrastructure in the beginning. You would productive from business point of view from the day one. Next one is about reduce costs. Serverless has a very interesting business model for payments. You're paying only for resources that you're using only for calls. And it means that in more classic server infrastructures, when you're paying for hours or you're paying for your hardware, usually your utilization percent of your infrastructure, it's about up to 30%. So you're missing your 70% of utilization. So you're paying for this, but actually you're not using this. And even for some cloud providers, it's it's a point for sale. So they are overselling their data centers because they know by statistics you would use your hardware only 30%. So they could say they are selling more hardware than they have in the data centers. And it's a totally different model in serverless. You're paying only for your calls, and it may reduce your costs significantly. And there are no, in fact, hidden costs like paying for network and for traffic. So everything is included and pretty straightforward. And for example, it may dramatically changes your cost. For example, I'm from previously in my previous projects where we've paid for our test environment about $1,000, maybe $10,000. But when we have a pretty similar solution with a pretty similar team setup, team's quantity, amount of developers, we are paying kind of hundreds of dollars. So it's a 10 times decrease. It's why that's why many companies looking at serverless model. Price reduce could be significant. Next slide is about improved reliability. With serverless scale automatically with you, so you're getting consistent performance at any scale. And the difference between traditional auto-scaling groups and serverless, so you have a very small smooth scalability transition. So it's not like steps when you are again having this utilization losses and price difference. Next slide, please. And to summarize all three items before, so I would say you have increased rate of innovation because innovation is about making experiments. And making experiments in serverless is that easy. So you got easily set up a new environment. It's very cheap. You're paying only for users, only for your resources that you are using, only for calls, and it makes your iteration cycle much more faster. And another point is serverless is a top of currently next evolution of cloud computing. So there are a lot of investments from a lot of companies. So and your platform will be continuously updated. You're getting new features for free. You don't need anything to get your platform faster. And there are a lot of improvements in this work. What is also important, your architecture by design is already divided into a lot of small pieces. So it's make easier for you to realign your application, and for example, to this team will be responsible for one part, another from another part of application. So your architecture is very agile by default, by the nature. Thank you.
The next session is about AWS Serialized design patterns and solutions. So what you do when you have a new project related to AWS. So from the very beginning, you meet with your stakeholders, you collect requirements, you identify architecture significant requirements, and then you start designing your solution, right? So for sure, you can come up with all the design yourself. And it appears that AWS has already prepared a lot of different patterns, so you can just reuse. And you then don't have to spend a lot of time searching how this piece of puzzles can be assembled together. So if you need to design some solution using serverless approach, for sure the first thing you have to do just to go to the specific pages, AWS documentation, and just find out. Probably AWS architects has already designed a solution for you. And in general, you can find such already existed designs in many areas like web application, mobile applications, backend applications, real-time stream processing, IoT platforms, machine learning, artificial intelligence, and data-related solutions. So the main idea, not just to invent a wheel, but take a look what already exists and just try to apply it to your case. And even if you already designed your solution and then you would like to go to production, you may just check. If I do everything right, probably there are some areas for improvement. For such purposes, AWS implemented an application lens like a part of AWS well-architectured tool, well-architectured framework. And a significant part of this framework is serverless related part. It's serverless lens. It's like a tool which allows you to evaluate your solution from 5 perspectives like operational excellence, security, reliability, performance efficiency, and cost optimization. It's like a bunch of questions you have to go through to answer them, and then you get the report back, and you can use this report to improve your solution. For example, in this report, you get an improvement plan with some areas of improvement with the risks. And these risks are ordered like high risks, medium, severity, and low risk. Also, you have a list of the most important risks, significant risks you have to deal with. In the details section, you get more details about each point of view, like operational excellence, performance efficiency, cost optimization, security, and reliability. You get kind of statistic with risks and also a list of all the details about the issues and the possible ways to improve them. So at the beginning, you may use already existing patterns, already designed solutions, and at the end of your design, you can just check if everything designed correctly using this serverless application lens. And also we have patterns, and also we have anti-patterns, and also we have serverless myths. And Dima will reveal all the details. Dima, please.
Yeah. So let's start with the myths. Serverless, so serverless, so you don't have servers, so it's probably automatically hosted somewhere. But in fact, of course, there is servers somewhere, and it has RAM and it has some resources, CPU, and this abstraction leaks in one spaces, some places. For example, for lambdas, you need to understand what actually your what are the requirements for your RAM for running your lambdas. So it is serverless, but you need to understand what resource are you consuming. And again, as Andriy mentioned, so serverless, it's not only about Lambda or Azure Functions or other cloud providers, Lambdas or functions. There are broad sets of technologies that that lives in the serverless world. We're discussing AWS right now, so so you should know a bunch of technologies when you are designing your serverless workloads. S3, all kinds of queues, including SQS, SNS, Kinesis. API gateway would be your friend number one. DynamoDB for storage, or or other technologies for storage. So it is all part of serverless. It's not just a Lambdas. Yeah, and we discussed in our business cases that's very cheap, but you also need to understand your workload. And so if you have very loaded, very high intensive utilization, maybe it's not a case for serverless. But as we are discussing, we are living in insurance world, so we have very consistent consistent workload for last 100 years, and so we could expect some load, so we could predict it. So serverless definitely works for us, and we are reducing costs, and all business cases are relevant for us. So that was 3 myths. And entry patterns. We would have 4 of them, and I'm going to discuss going from the first one, going stateful entry pattern. So Lambdas, you're not controlling whenever you you're not starting Lambda by yourself. So it's a black box for you by the platform. So and you would have a new Lambda on new server each time. So please don't consider Lambda as something that could be stateful. It's stateless by design. It's stateless by the nature. In serverless, you need to consider use other technologies for your storage. Either it would be cache, either it would be your database, whatever. So all states should be external. The next entry pattern is it's about not paying attention to the specifics. You should know that there are a specific amount of restrictions, a specific amount of rules that you need to know. It's not only about serverless, it's all about all cloud technologies, but in serverless, it's take very important places, even on designs, even on design phase. So you would start, you need to understand what your request size limits, what is the maximum execution time for your Lambdas. So you should always keep in mind these numbers and revise this information. It changes rapidly, and it changes in a very optimistic way. So you would have maximum execution time increased, request size increased. So in this case, it's getting better every month. And consider whenever you're developing your serverless workloads, you are switching to the new paradigm, to the new world, and maybe taking big application servers with you, it's not a best option. Serverless is about very fast responses. It's about event-driven approaches. It's about very quick start time, because it's very affects your calls. You're having your bills in milliseconds, so reducing your workload from even from 500 milliseconds to 200, it will reduce your costs more than 2 times. And the same with memory. So with applying serverless approaches to your architecture and to your workloads, you need to consider the very lightweight approach for development of specific tool sets. Multi-threading is not an option with this thread leaps and other synchronous patterns. You should be very event-driven. You should be orchestrating your workloads, not your imperatively in your code. There are a bunch of tools to configure Lambda executions. You don't need to do this by yourself. There are step functions, a lot of messaging technologies. So don't do orchestration by yourself. Please delegate this to the platform. And again, having this weights and the throttles on your Lambda execution will increase your cost significantly. So you need to redesign it. you need to consider this anti-pattern before you're starting implementing your application. And next section about design errors.
Yep, thank you, Dima. So probably you think, so guys told us quite obvious things like use existing patterns. There are some myths and anti-patterns, and so don't do it that way. So in this section, let me show how those things are important and why those limits to serverless world is very important as well. And in this section, I'll tell you a story about one error, about one design mistake, and we'll try to play a game, as in this case. So let me start from the business context. We have internal service and this one, and external service, this one. And the business wants us to integrate those services. So external service will make a call through the internet to our internal service according to some rules, to some constraints and requirements. For example, internal service API cannot be exposed via internet because of some security restrictions. Also, this internal service cannot be modified. And sometimes internal service can be shut down for maintenance according to some schedule. Also, we have a bunch of requirements. For example, all the requests are to be authenticated and authorized via OAuth 2.0 approach. The load is not big. It's like about up to 100 calls per day. Request size is about 10 megabytes of data. Also, client wants us to build a cost-efficient solution with 24/7 availability. In this case, serverless approach works very, very good. So we came up with such a design. So let's take a look what it does. So we have like external service, which sends requests to our integration, but it consists of API gateway, which is exposed according to some rules to internet. We have attached authentication Lambda to this Amazon API gateway, which verifies requests via SSO. Also, we have our Lambda, which processes requests from the external service, writes the body to S3 storage, and writes some audit information into Amazon DynamoDB. Also, we have Lambda, which works according to the scheduler, which reflects the time internal service is up and running. So this Lambda, which works on schedule, checks information from the DynamoDB. You remember there is some audit and status information there, takes data, messages itself from the S3 storage, and writes to internal storage according to some principles. So let's check if this solution satisfies the requirements. Authentication. Do we have authentication here? Yeah, we have it here. Up to 100 calls per day, for sure. This solution can process even more than 100 requests per day. Request size up to 10 megabytes. It looks like everything is okay. Amazon API Gateway can accept this amount of data. Cost efficient? Yeah, If there is no calls, we pay just for storage, and that's it. If it's available, yeah, it's high available. Did we modify, did we expose our internal service to internet? No, we satisfy this constraint. Did we modify the internal service? No. Did it work according to schedule and we can support this functionality? Yes, we did. So is there anything wrong with this design? So guys, please write your suggestions into the chat. So you have a couple of minutes. So please write your suggestions, and at the next slide, we will discuss where the problem is. And while you're
yeah, I want to remind that we have some lag between our broadcast and chat, so let's wait while guys will write something. And yeah, and while we're waiting, we have some questions. Do you mind to answer them? Some of them.
That's great. That's great. Yep. Let's
yeah, to be honest, we have a lot of questions, and so I'm really glad about that. So guys, don't hesitate to write your questions to the chat. And yeah, we start receiving answers on your questions. So let's talk a bit about questions which you have in the chat. The first question which we have is when not to use serverless.
For example, there are some cases, even with this client, where we use serverless approach very widely. When the load is quite permanent and it's quite high, it means Lambda will be working like 24/7, and usually Lambda costs more. So it means we'll pay several times more if Lambda works all the time from the morning till the night. In this case, just looking at the load, we use ECS containers, for example, at Fargate. With Fargate, or we use other not Lambda functions approach. But in general, this is about functions and containerized solutions. Also, serverless databases sometimes doesn't work because they have a big start at the beginning. So if it's cold, your database is cold, it has to start. It has to load some data into memory. So sometimes it takes up to 5 minutes in our cases, and it wasn't appropriate for us. So we had to go with usual database engine, not serverless.
Okay, thank you very much for the answer. So I think we have some answers for your question, but before I start telling them, could you repeat your question so we'd have a constant?
Is there any problem with this design? This design has an error, a mistake, a design mistake. So please write your suggestions into the chat. What the problem is.
So which answers which we have in the chat, I will just read them aloud, okay? So first answer was 10 megabyte versus 6 megabyte, and I think it's that 10 megabytes request is too big. Another answer is Lambda cannot accept more than 6 megabyte. Another answer is, I think it's about 10 megabytes requests too big for request payload limit. Maybe it's about that, or it's just another thing.
So Roman, we have a great listeners. We have a great viewers. So
yeah. So we have another answer about request limitation by Lambda. Maybe we need to use SQS instead of S3. Okay. Yeah, and we have another thing I don't know if it's a question or it's an answer. It's a question to you or it's an answer for your question, that if internal service is down, you will retry your Lambda every time. And also we have that 30 seconds Lambda timeout. I'm not sure what does it mean. So Justinas, you may you clarify your question?
Yeah, that's correct. This is another very tricky part, that our Lambda will work will be idling for the time that internal service is down. That's right. And for such purposes, we can change this design, but it still works. And this is place for improvement, but it's not a mistake of this design, which like mistake, I mean, which contradicts the initial requirements. But I'm really happy, and Dima said, already said that, guys, right. So the problem with the body size, which can be processed via API Gateway and AWS Lambda. So, yep. Let me like highlight it. If we take a look at API Gateway limits and at Lambda limits, we can see that payload size at API Gateway could be up to 10 megabytes. But if we take a look at our Lambda limits, we can see that only 6 megabytes can be processed synchronously. And it means the problem is the problem with the design that if you send 10 megabytes of data, it cannot be processed via Lambda. That's it. So great answers. Thank you very much. And what possible ways to improve? Actually, there is no, like, there is a very well-known institute, Software Engineering Institute, which has a lot of educational courses for architects, and great architects work trainers there. For example, there is Rob, who designed solutions for the United States military forces and even for their like cruisers or destroyer ships. And he said, there is no good or bad architecture. There is architecture which satisfies requirements or doesn't satisfy them. In this case, this architecture is bad because it doesn't satisfy the initial requirement about the payload. But this one, it's like good because it satisfies, but also it means there are many other architectures which can satisfy those requirements. So if you give one task to like 3 architects, for sure you will get 3 different designs. Are they good or bad? Of course, if they satisfy the requirements, they're good. And you cannot say this design is better than another one. So if your design satisfies the customer requirements, your architecture is good. So let's take a look what we have here. So in this case, the body writes directly to S3. And in this case, we have like, we have no restriction with 6 megabyte payload for Lambda. And we have an S3 generates an event when a new file appears in the storage, and Lambda listens to those events. And in case of a new file in the S3 storage, the Lambda writes audit and status information into Amazon DynamoDB. And our Lambda, which works on scheduler, takes like audit information, takes the body data, and writes to internal service. So in this way, there is no such limitation. Lambda just reads like data from the storage, writes, oh, here it is, yeah. Reads data from the storage and writes to internal service. So that's fine. And also, there is another interesting point you highlighted already. So there is a dedicated section for it. What shall we do with Lambdas and our internal service? If internal service is down, does it make sense to run Lambdas? It's a way to improvement, and you already found it. So let's talk about integration between serverless world and legacy world. So for example, let's take a look, let's compare these 2 worlds. Serverless solution, it's high scalable, high available, flexible to workload. And what about legacy systems? Usually they have a maintenance window when they're shut down for some kind of support. Also, probably they cannot scale as quickly and so much as serverless solution can. For example, you cannot process, even there is some concurrency limits. in our internal system on customer side, we have a system which doesn't allow to process more than several requests concurrent. So if you want to process more than that number, like more than 5, you can get just timeout response or something like this. And the next point, it's about unexpected 500 responses from the legacy systems because of some reasons you don't know, and probably no one knows because people who wrote those systems probably are retired, and there are no one anymore who can just tell you why this 500 errors happen or why unexpected timeouts happen. So lack of knowledge is also like a usual case when you work with legacy systems. So what shall we do in this case? So many patterns can provide us support in solutioning such problems. For example, idempotency. If you write a message to a legacy system, and if it's idempotent, you can write it again and again until you get a successful response from the legacy system. If your message is not idempotent, so it means if you write once, you have to understand, did you write successfully or not? So you have to search or to try to get this information back. And if it's there, you wrote it. If it's not there, so probably you have to make another attempt. Also, you may use asynchronous communication and put like a queue between or another AWS service between serverless world and legacy world. So when your serverless solution scales intensively, you get a bunch of requests or messages into the queue, and then you process the request in asynchronous way in time when your legacy system is up and running. Also, you can use bulkheads in your design. You can just divide your solution into pieces. For example, if one piece scales a lot and another piece cannot scale so much or just cannot process it in so quick way, you just decouple them within some pattern. Or you can use, for example, if you'd like to write to legacy systems, which sometimes goes down, you can use a very well-known pattern. It's circuit breaker pattern. So if you write to the legacy system and writes are successful, circuit breaker pattern does nothing. But if you write and your write fails, circuit breaker pattern fails your next requests according to some timeouts. And in this way, you get fast fail response, and you don't have to wait for timeout. So these patterns will help us to design the solution, how to integrate our serverless world with our legacy world. And if you would like to learn more about one such patterns, how we answered the question, how to build efficient writing adapter to the legacy system, which works according to schedule and doesn't waste time and money. So you can take a look at the circuit breaker pattern implementation. I did this presentation at the Community Z platform as well. So you have a link and you can dive deeper into the details. Thank you very much. That was a great game. And actually 2 people really came up with the right answers. Thank you very much. Dima, please, it's your turn now.
Yeah, serverless DevOps best practices. So I have, there are several best practices that I want to share you, everything based on our hard work and the experience. So let's get started. And the first thing that I want to share with you is serverless application model. So writing to automate your deployment, automate your pipelines, you need to write a lot of CloudFormation code and to describe your workloads. And serverless application model that's actually built on top of AWS CloudFormation make it so much easier and so much time effective to write it. So it's summarized. So you need to write less CloudFormation code. It's more serverless specific. It's included. It includes some built-in best practices. So some example, for example, automatic policy creation, and you have everything in one file. And the most important and killer feature is you with serverless application model, you could actually debug and test your Lambda on your local machine. So local testing and debugging, it's a thing, so it's real for at least for Lambdas. So check the links about this serverless application model below, and it's continuously updated, adding new features. So it's a very good start to using AWS Lambdas. But when you are becoming more mature, I would discuss next slide about AWS CDK. It's Andrew, do you want to say something?
No.
All right. So you need to understand the difference between CDK. It's cloud development kit. It's not software development kit. So it's CDK, not SDK. So this is another. It's not only about Lambdas. It's a technology that allows you to describe CloudFormation not in YAML-like code. You could describe your workloads by using programming languages. So the same programming languages that you're using for your business logic, for writing your application. So you could use TypeScript, JavaScript, and other languages to describe your workload. Why it's important? Because it's very reusable. So you could describe specific patterns. For example, you could automatically you need to. For all your API gateways, you need to specific integration, for example, with Ping ID that Andrew mentioned as an example. So you could easily write your component, your function, your class, and reuse it as a library, reuse it everywhere. So it's a very dynamic, very power tool that you 100% want to try when you're using big when you're writing big serverless applications. So it's making your CloudFormation, and it's the idea of this tool. So it actually compiles to the CloudFormation. So it's transpiler from your programming languages to the CloudFormation. So you could reuse parts. It's easy to write, and it makes your infrastructure consistent by reusing parts. And actually, there are several libraries that you could use. One from AWS, one is independent. AWS created solutions construct, where you have all very popular patterns such as pre-create Lambda and SQS and subscribe Lambda to this SQS. So in CloudFormation, you need to write a lot of CloudFormation code to create these scenarios. You need to write less code in CDK, or you could reuse it in 3 lines with this solution construct library. So it's very useful. And there are another library, CDK patterns, so you would also may consider to look at this. So they are very dynamic. You have new patterns every day, so they are available on GitHub, so you could contribute to this. So you could so I would definitely recommend to when you if you are deploying, if you're creating big serverless workload, to create the similar library, or to reuse this library, or to do both, reuse and create your library for your specific set of components. What is next slide about nested stacks? I do not want to discuss this very important feature by details, but I would recommend you to check this functionality, and this helps to describe dependencies between your workloads. So once again, it's a very important. Next slide, please. And again about limits, but now we are discussing limits not on Lambda levels. We are discussing account level limits. So, for example, on your specific AWS account, you have a limit of you got to continue in the same time running only 1,000 lambdas. That's a soft limit. Hard limits are much bigger, but you should consider these numbers when you're deploying infrastructure. Unfortunately, so we've learned these limits in a hard way. So we've stuck in almost each limit. Probably the first limit that you will try at would be NI, Elastic Network Interface per VPC limit. So you're usually creating lambdas and specific VPC with specific shared security. So and it automatically creates Elastic Network Interface. So you probably don't even know that this NI Elastic Network Interface exists, but and you could take your limit, take this limit, and what I want to add. You need to consider good AWS accounts design strategy. So you probably having not having one account for big company, it's not an option. You need to divide your AWS accounts, divide into smaller pieces, smaller chunks, maybe department, maybe project. So it's up to you. But know your limits. It's very important. So I do not want to repeat our mistakes. And the next one, it's about the next tool is AWS Lambda Power Tuning. This tools that we are recently very hardly using to optimize our Lambda sizes. So as I already mentioned, for each Lambda, you need to assign specific hardware resources for RAM, and you need to understand actually what the optimal way, what's the optimal size of the Lambda. And for each Lambda, it's individual. For some Lambdas, the need should be very fast. For some Lambdas, they should be cost effective and running time period is not important. So this tool help you to identify these numbers. So these two are continuously doing some performance testing on the Lambda and try to run your Lambda with different RAM configurations. So, and after that, you're getting graph that you're seeing at the right. So you could find what's the best cost-effective RAM size, what is the best RAM size from time period, from running period amount, and what's the worst time So it's based on these numbers, based on this report, you could make your best decision. So I suggest to use this tool for every Lambda that you have. Another slide's about DB connection management. As we discussed, we are going to use our external storages, and in case of if you are using just Aurora or RDS, you could have an issue with connection pool management. So your Lambda scales very quickly, which is not supported by default RDS implementation. So you could have a 1,000, for example, 1,000 Lambda executions for short amount of time, and each Lambda execution requires connection string and so on, and it's this connection pool size, it could be a problem. So but don't worry, a lot of solutions for this issue. Aurora serverless release has been released, version 2 recently. There are data API or DynamoDB also works good with this specific scenarios. So that's it about DevOps practices. So we have learned it in a hard way. So please revise this presentation one more time and do not repeat our mistakes.
Yep, thank you very much, Dima. It was like probably the most interesting section, not make our mistakes. And you see our like requisites, contacts, people who conducted this presentation. So Roman, do we have any questions?
Yeah, so first of all, guys, thank you very much for such nice presentation. Thank you very much again. And I really hope it was useful, and we have a lot of comments in our chat. So guys, if you have any questions, please type them in chat, and please use #question, so I would know that it's a question to our speakers and not just discussion, because we have like a really big discussion there, even with answers. So just go to the chat if you guys want and have a look there. Okay.
And
so,
Roman, I have Telegram channel too, so please subscribe to my Telegram channel.
Yeah, you may post a link there to our. So just send the link to me. I will resend it to.
It is present on the slide. So.
Oh, okay, guys. So yeah, please join there. Okay, so before we proceed with questions, I want to say, so guys, thank you for being there again. Here we have a subscribe button, so please subscribe not to miss our next webinars. Yeah, and so let's proceed to the questions. Okay, so I need to scroll up a bit because we have a lot of discussions there, as I mentioned. Okay. So what is the deployment strategy recommended for serverless pattern, blue-green or in place replacement or whatever?
I would say we have test environments where we have a blue-green deployment strategy, but in fact for production we are rewriting everything, so it's in place.
Okay. What is your strategy for serverless apps management? Say you might have dozens of microservices, but hundreds of serverless apps. Even code maintenance might be a challenge.
Yeah, SDK, nested stacks, and we use kind of currently monorepo approach for running our workloads. It's not monorepo for all companies. It's mostly team size repos, but we have a lot of several workloads in one repo. So writing CDK code, reusable, and nested stacks helps us a lot.
Yep, and also actually the initial problem was with microservices as well. When for a big client we may have like hundreds of thousands of microservices, and within Lambdas it like dozens of thousands. Probably that number could be achieved. and it means probably nobody knows what they do. So for such purposes, there's a recommendation to have a portfolio catalog.
Yeah.
So with some capabilities like to search, to see connections, interconnections between lambdas or services. So it's like a site you can see the list of all lambdas you have with some tags, with some relation to departments, to business functionality, to domains. So domain-driven design also helps you to organize your lambdas, your services into some groups, and you can search like do some kind of advanced search through all this portfolio to understand if you need to implement new logic, or you may reuse what already is in place.
Okay, one more question about deployment strategy. Is it possible to deploy serverless with canary deployment?
Yep, for sure. Dima, please go ahead.
So you mean traffic redirection, so you want to try it before. So you could use, of course, you could deploy several environments at the same time on production and do this traffic redirection with API gateway or other tools where you are using API-G for these cases. I personally haven't tried it because we are doing this very specific business applications. We don't have a lot of theories that we want to check, so we are just focusing on specific sets of requirements. But yeah, I would say this is definitely possible. So.
And also we use canary deployment approach at high level of details. For example, the whole program, like a very big project. Dima is like chief architect there, and at that project, the canary deployment is implemented in the way that we have two working solutions in place, the old one and the new one. And in alpha version, just some dedicated requests went through the new system. And in June, when the release is scheduled, probably one request from one United States state, Arizona, will go through the new system. And then if everything is fine, all monitors will show successful results. The solution will be applied, the new solution will be applied to other states. So probably canary deployment can be used at many levels of details, at levels of a program or big project, or like at the level of services or Lambda functions, because it's up to you. You can configure API gateway, create routes in the way. So some like every 5% of requests go to a new solution and other 95% goes to your old solution. But when we are talking about canary deployment, a lot of people know this strategy, but forget about the backside of such approach, because we have to monitor. Really, we have to not just monitor. We have to understand what criteria, what metrics we have to monitor in the new and the old solution to identify if a new solution works proper. And also we need to have a process like to switch to increase traffic to the new solution or decrease it. So canary deployment usually is a much more complicated approach than Greenbull.
Yeah, and I want to add, there are a lot of questions about deployment strategy and about deployments, but from our experience for last 1.5 years, it's solved the issue. So we don't have any issues with deployments anymore. So start with the SAM, then use AWS SDK, consider reusing nested stacks, and it just works. So we are not spending a lot of time on deployment issues right now. So we don't have it. It works.
Okay. Thank you very much, guys, for your answers. We have multiple questions about the following topics, so I would like to combine them. which language, let's say, is the best for AWS Lambda runtime? Is it Golang or AWS Lambda written in Java? Is it okay or not? So what would you say about that?
The best language is what your team would prefer. So it depends on very depends on your team skill sets. We are using probably all of them. So we have this one team that are writing lambdas in a TypeScript and Lambda and Java in Python at the same time. So we have we've created. So we started with the Java because team was Java. They have a very specific Java skill set, but then they've migrated more to lightweight approach. We haven't tried Go yet, but we have TypeScript lambdas and Python lambdas, and it's also limitations for our project because we have all the infrastructure code written in TypeScript, all CDK code. So it's easy for us write lambdas as well in TypeScript. So because we could reuse one tools for linters, and so it's but Java a little bit. It's more memory consumption, and less, not so speed as other technologies, but it's your team skill set is very important.
Yep, and also you have to think about your client and how client will maintain all the systems. For example, in the case if we designed and developed solution for data scientists, at our client side, we usually used Python because data scientists know Python and they wanted personally to support the system we built for them. In other cases, we used TypeScript for our lambdas just to avoid some issues with Java. So everyone knows about cold start, but from like high-level perspective, when we see many teams which used Java a lot before, Spring Boot, Spring Cloud, etc. And when they switch to serverless world, we find out that a couple of teams put Spring Boot inside of Lambda. So you can just imagine how long this Lambda starts. To start the Spring Boot, to get up all the context, etc., etc. So probably knowing Java very well, it played like a bad joke on us, and actually, if complete the speed of development using Python, TypeScript, and Java, Java probably doesn't win. But from other perspective, TypeScript and Python are harder to debug.
But there are some cases when you have a very specific library, for example, for supporting your data format, and you need, it's very important. So don't stick to one language, be language agnostic. For example, if specific language have specific libraries that are game changer, so consider using this language in lambdas. And what we've done, we've created a page where we have a default option, default language for lambdas. But if in case we have a kind of checklist which language to choose, so that it works.
Okay, thank you very much for the answer. I want to say that we have seems to have some experts in YouTube chat, who answers some of questions, and I want to thank you guys for being proactive. So you ease the life of our speakers. They don't have to answer all the questions. So thank you very much. But anyway, I want to pronounce some questions, so we would have some answers here in streaming. So. Oh yeah, I found it. How to better adhere dry principle and share common code between different lambdas? Copy utility libraries to every lambda or something else?
Lambda layers.
And also there is like recently there is a new functionality was released, Lambda extensions. Am I correct, Dima?
Yeah, but it's more about monitoring tools. So it's yeah, it's Lambda extensions, so Lambda layers, the things that we are using right now.
Yeah, so
The
we have
libraries
same.
and
Yeah, we have same answer in the chat, so I just want to pronounce that. Okay, so as far as I see, we have all questions answered. Yeah, so I think we may wrap up here. So guys, thank you very much again for this such a nice webinar. I hope it was useful and really you guys love it. So we have a lot of likes and a lot of comments. So thank you very much, guys, again.
thank you, Roman. So it was
Thank
very
you.
great experience.
Yeah.
Good luck with your future webinars.
Thank you. So waiting you for another webinars, and you're really welcome always. So I just want to say, guys, that thank you very much for attending this webinar. I hope you love it. So please subscribe to our channel, put likes for this video. This video would appear on the channel like right after we finish the stream, so you may review this. And also, if you register through Community Z platform, you would receive the feedback form. So please fill it. We always read all the feedbacks and we try to react on them and make our webinars better. So please spend just a couple minutes from your life and fill this feedback. So we would have your opinion about our webinar, and more webinars are coming. So subscribe to our channel. More will be here, and also subscribe on our Telegram channel here in the description. There will be news and stuff. That's it. Thank you very much, everyone. Andriy, Dima, thank you very much for your time and for this such a great webinar. Thank you.
Thank you very much.
Thank you. Thank you.
Bye-bye.
Bye-bye.
Thank you, guys. Have a nice day. This is wrapping up this webinar. Thank you very much. See you on JACOV channel. Bye-bye.